So at this point, I think I'm ready to give a shot at soldering on this BGA. I have never soldered a BGA before, either taking one off of a board or putting one on a board. So this will be an interesting experience, I'm sure. This board at the moment, though, if I power it up, I'm getting all my rails correctly. I've got a power good indicator. I have indicators for 5 volt, 3 volt, 2.5 volt, and 1.2 volt. And I'm very close on all the voltages. So specifically, I'm at 1.1966 for the 1.2 rail. I'm at 2.5472 for the 2.5 rail. 3.3268 for the 3.3 rail, and 4.9922 for the 5.0 rail. And those are all very close, well within a couple of percent from the target I was shooting for. So I'm comfortable that power-wise I'm good. I've done a load on all of these between 0.5 amp and 1 amp per rail, and everything is running fine. And so I'm going to step forward with the next step then. And so that means I need to grab one of these little guys, which just look tiny. Again, I've got 121 pins here, or balls in this. And if I look at this under the scope, this is what I have to work with. And what you're seeing here is that I've got 121 pins, and really all of these center ones are a via in pad. So there's a via right inside of the pad. And I don't think I intended it, but I somewhere along the lines must have put via in pad for these few down here. That really wasn't necessary, but I must have done it and not realized it, or wasn't paying enough attention. Not going to cause a problem, but probably was just unnecessary to do that. But I now need to get one of these out and get this soldered in. And the things I'm thinking about as I get in and do this, I guess as I consider this board, the things that I'm going to assume, and maybe I should double check this, I'm going to assume that these come with the solder balls already on there. That I can't imagine getting a BGA that wasn't already set up with all the solder balls. So I'll just put this under the scope and let's take a look at it. And so this is what I'm working with. Just turning that here a bit, and I'll adjust the focus. Balls are all there. Looks like ready for me to take a run at this. And so I'm going to have to take that and get it soldered onto here. Now, the balls on that, I assume, are not leaded. So they're, I'm sure, a lead-free, so it's going to have a higher melting point. And I don't know if the spec sheet tells me what they are as far as material, but I'm going to assume it's a lead-free solder that I'm working with. My board that I'm working on here, everything is leaded. Pretty much everything I do is with lead. So I know that some of this stuff, I have to be careful that I don't basically damage this or break free any of the solder connections as I'm trying to put this on. And I have some stuff over here that's pretty close that may get messed up in the process, but I can fix that when I get done with this. If I was going to take a future board and do it again, now that I know that this power setup seems to be okay, the very first thing I would do is just the FPGA by itself, and then I would get everything else on. So FPGA first, followed by the regulator over here. Since that's a QFN package, that's kind of the order in which I would solder those, and then the rest is just time consuming. It's not super difficult. So what my intention is, there's maybe two ways I could approach this, or could have approached it. If this was a blank board and I was starting with the FPGA, the IR oven is an option that I could use. Being that I've already populated this, though, I don't want to throw this into an IR oven. So what I'm going to do is I'm going to use a hot plate and set this on top of the hot plate and then warm it up. And as far as the temperature that I plan to warm it up to, as I'm thinking through this and just kind of looking at some of my notes, leaded solder melts at around 183 Celsius. Now the lead free is at 217. So I have to make sure that on the hot plate I keep under 183. Maybe I'll say 150, just enough to warm this up but not melt the solder that's already on the board. And then I'll use the hot air gun, and I don't know what temp I'll necessarily set that at. Probably something between 350 and a little bit above that. 350 to 450, somewhere in there. I've got to experiment. But I think with the hot plate, that'll just warm it up and make it a bit easier to get this melted. And then I'll use the hot air gun to try to get that done. And then once I get that done, I've got to turn around and add in the SPI flash. There's a few capacitors, resistors, whatever. On the back side of this, I'll probably just populate there's I think a couple of pull-up resistors or pull-down resistors I have. And then I'll put on some of the caps. I'm not going to put all the caps on, but I'll get some of the caps populated. And it looks like I've got 3 larger caps I need to worry about here. And that maybe is about it. And then maybe I'll sprinkle in some of the smaller 0.1 type of capacitors in here just to get me out of the gate. And then, of course, I'll need the header in here for programming. And I've got this set up for jumpers, but honestly, I'm not even ever using those. So I might, for now, just actually set these without jumpers. We'll see. So either jumpers or I'll just put in little shorts on the way that I want to kind of hard set it for now. And if I need to come back to jumpers, I can always put those in. In the next revision of this board, I am going to go to dip switches instead of jumpers. So I have some 3-way and 4-way dip switches, or 3 switch blocks and 4 switch blocks that I can put in instead of this. Just a nice little switch block instead of these. If I get that far, then I'm going to try to program the SPI and then see if I can get this to start up. And there's going to be a C done LED up here that should hopefully light up. And see if I can get that far. And then following that, of course, would get an actual one of my I/O headers and some test LEDs running up here. And that will be a huge win if I can get to that point. But right now, the big hurdle is the FPGA itself. So that's what I'm going to do right now. I'm going to bring up the hot plate, get it warmed up maybe to this 150-ish, and then get my hot air gun, put down some flux down here. I've seen 2 different approaches to it. Some people seem to say just put a very even thin coat, and I see others just lathering it up with lots of flux. I think I'm going to go with the former of those 2 approaches, which is just an even thin layer across this, and then see if I can get that to melt and settle in on this FPGA, basically set of pads that I have here. Okay, so let's give this a shot. Okay, picking up where I left off. I did go ahead and populate the oscillator in addition to where I left off before, and I do have this debug header on here. I have programmed the SPI, which you can't see. I have it under this Capcom tape right now. And programming went through fine, but then when I went to actually turn on the board, I was getting no output over here. And I'm not really sure how you would troubleshoot real effectively. I think there's some stuff I've got to learn about how would I troubleshoot whether or not I've got proper connections to the balls and things like that. And I've seen some initial things I can read up on that, but I have a lot to learn there. But I was not having any luck. So I decided I would heat up the BGA and get it hotter than I did before. And I think before it really did not get hot enough to actually melt the balls the way that it needed to. And as I was doing that, I was getting it warmer, and I went to touch the BGA with some tweezers, and it actually shifted, and a bunch of the balls rolled out, or it looked like a bunch of balls rolled out. So that wasn't good. So I basically pulled off that BGA and quickly cleaned up the pads and kind of started placing another BGA. So here's the BGA that I pulled off. Just going over to this. So this is one now that I will have to go back later and clean up and maybe reball it, or see if I can just clean it up the way it is. And so that'll be a good exercise for me to do to see if I can get that cleaned up. And it looks like it's not going to be too bad to do that, but I would like the practice of doing that. But back to this one then. So what I did as I went through this is, I did tape off everything but the BGA. And let me go ahead and pull this tape off and see if I can do it without damaging anything. So this is now what I have, and it needs to be cleaned up because I had a whole bunch of flux on here, and that flux is quite dirty at this point. Burnt, I should probably say. And maybe I'll just come in here, and I can see that's going to take a little bit of work to get that cleaned up. But I don't think that's going to be a big deal. I'll get that cleaned up just fine. So yeah, that's cleaning up just fine. Camera might have a lot of reflection there, but it's just basically flux that I need to get pulled off. But what I wanted to do is real quick turn this on, and I did this right when I got done letting it cool off a little bit just to see. And I'll go ahead and turn it on, and I am getting these LEDs on. And right now, and I can see my camera refresh rate picks that up a little weird. So turning it off, turning it on. They're moving pretty fast on what I'm looking at, and on the capture there, it looks like it's kind of just kind of strobing back and forth. So maybe what I'll do is real quick slow that down. So I'm going to stop here and then start adding the computer to my recording. Okay, so I'm going to go over to iCE40, and this is the pinout I'm using. So real quick, I'll run through this real fast here. I set up a constraint file, and the constraint file just simply says pull in a clock on pin F3 or ball F3. Grab these 8 balls on the bottom to connect to basically LEDs. And then I went back and I put in really simple testing code. And that simple testing code just says bring in the clock. And I'm going to have an output of 8 signals for LEDs, which will map to these 8 up here. I've got a counter, and that counter is what's going too fast. So I'm going to increase that number. And then all I'm doing down here is just simply telling it to strobe across the LEDs. Well, right to left or left to right. I'd have to double check which order it's going here. I think it's right to left. But let me save that. And then I'm going to go back over here and do the synthesis. And then I will do the place and route. And that'll take just a minute. Now, when I did go back and redo this, I did put it on the hot plate again, and I just had, again, the hot plate at 150. And I had already put all these caps on the bottom, and they're dark because of the flux I had on there got pretty burnt. So I'm going to have to just clean that up when I get a chance. And I think everything else is looking okay. There's maybe some pins down here I might want to go touch up a little bit. But I'm not seeing anything shorting or anything like that. So I've got cleanup to do. I put this on and these did not fall off or anything like that. Again, I set the hot plate to 150 and then I used the hot air gun on top at like 660. So I had it pretty hot and I was trying to, check the temp as I went with this just infrared temperature reader. And as soon as I started seeing it getting above that 217 or whatever it is for melting of the non-leaded solder, then I kind of backed off and let it cool down. Okay, bitmap completed. So I'm going to go over to the Diamond Programmer quickly. And so here's the Diamond Programmer. And I did one weird thing on this version. The header is flipped or turned from my other board. Not a big deal as long as I remember that, but I shouldn't have done that. I should have made it consistent. So I just got to remember to turn this 180 degrees anytime I'm going to program it. So I plug that in, I apply power, and this is showing that I've got both going on. I'm going to go ahead and then say program. And again, I should see these blue lights flashlight or flash when it gets programming here. So it's preparing to do that. That looks good. Okay, so operation successful. So I'm going to turn this off. I'm going to pull the header and then back over here. I'm going to go ahead and turn it on. Now I must have my mapping incorrect. I'm kind of laughing. You can probably see this. It's I'll have to slow it down, but it's the order is wrong. So I'll have to look at that here real quick. But what I have as successes here is I've got power good. All four of my power rails, their LEDs are lit up. There's a C done down here that is lit up. It's really dim, but it's lit up. And then this appears to be hitting every LED. It's just not in the order I was expecting. So I might go back here and see if I can figure out what's going on there. So this is the board, and I'm coming up here. And actually, I might take this header off. And I have this other style of header that instead of just putting them all in a row, tries to lay it out more by the physical, how these pin headers are set up. Okay, so that you can see there, that's good enough. I'll just leave it at that. If I wanted it to scroll those in order, I got some pin mapping orders that are just a little bit backwards. But basically you can see it's bouncing through all 8 LEDs. So I'm cycling through that code just fine. And again, if I go back to that code, this is simply what it's doing. And on this other one, it didn't go in the order I was wanting it, which just tells me that I've got this mapping here, maybe to the wrong pin. So I'm going from B5 to A4, and B5, A4. So if I go look at this, so B5, A4, so that'd be 208, 211. .208, 211, and I probably want to swap that around and go 211, 208. And that's probably correct. So I've just got these the pin order out of the order that I would want to see it for this other one, but that's easy to deal with. It's just the order in which I map those. So if I wanted to fix that, let's see if I can do that real quickly. It might be more like this will be 1, 0, 3, 2, 5, 4, 7, 6. That could be wrong, but let's see, 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to go back and I'm going to do my, I don't know if I have to do the synthesis again. I probably don't, because I think those pins are used during the place and route, but I'm not sure. I'm going to do it anyways just to be safe. And I'm going to go ahead and turn off my board. It's running the placer. While it's doing that, I'm going to flip over to my programmer screen and get my programmer hooked up. Like so. And in the background, I can see it's running the router at the moment. Okay, done there. I'm going to go ahead and apply power, do a program. Programming complete. I'm going to go ahead and turn that off. Now this, with this LED header, it looks the same, but then the question is on my other one, do I get the nice sequence I'm expecting now? Yeah, there we go. Okay, so I just corrected that pin mapping, and obviously I can go back to that file and put those in an order of 0 through 7. It's just the assignments of the which balls I just had to clean up a little bit. So this makes me really happy. I have, for sure, what I have working is the core of the FPGA is working. It's bringing in a clock on one of the pins or one of the balls here, and that would be one of these global pins. And if I go back over here, I can look at that and see that I have that going to the global N7, and that tells me that it's F3. If I go back over to my iCE40 software, I can go up to the package view and I can look for that pin. And again, that pin is F3, so it's this ball underneath the package that is coming in. My 8 LEDs are these other green with the padlocks, so that just shows me which balls are being used there. So I know that much is working. I know I'm getting my clock in. I know I'm getting my LEDs out. Chances are, if those worked, I have some confidence that others here should be fine. But it could be that the lower right, maybe there's balls down there that aren't quite hooked up right or something that I would have to work with. But I guess I've got my SPI pins down there. I'm just looking at this legend over to the right. It's showing that SPI is on these pins, and that's got to be working because it's reading my program off my flash. So I know that the left, the upper left, the lower right all those pins have to have soldered okay. Those balls had to solder. So I'm feeling pretty good that this, is sitting in pretty good shape. So I'm really happy with that. My lesson learned was these probably can take a lot of abuse as far as heat and soldering. I probably need to get them hotter than initially feels comfortable. But it seems like this one I got quite hot. It melted and looks like it did what it needed to nicely. And now I got this other BGA that I can go in and clean up, reball it, and maybe put it on another board. Maybe to make another board that's just a clean build, and see if I can make that work fine. I think what I'll do next then, since this is so far so good, I'll populate one or both of these, and just to grab one of these for a second. It's just a connector that looks like this. I'm going to turn off power, but I could probably just put this in here real quick. Okay, so something like that is what that's going to look like. And I'll have two of those. And this one here is taking two of the banks. So probably I'd have to double check the schematic, but the top and right. This one, well, yeah, that's what it is doing because I can see the traces, top and right. And then the left and bottom are going to come out down here on the bottom. So I'll have two of these. And then I can turn around and, build add-ons here that would go into that. So I'll talk more about that in another video, but that would be the next step for me, is to get this populated, get the rest of the capacitors. I didn't put them all on here, so I'll do some cleanup. I'll put the rest of the capacitors on. I have a couple more headers to put on, but this board is almost completed, and now it's really just testing and seeing what works or doesn't work the way I'm hoping it would. And if this is working and these headers appear to be working, I do have a test card that I can use. Then I'm going to design up a couple cards that will let me do things like that VGA circuit, just a click-in card that gives me all of the digital to analog, the DAC, basically the resistors for the VGA output, the VGA connector, maybe some static RAM on that I could use as video RAM, whatever it might be. Maybe another card I could do things like have some of these types of just regular headers I've been using. Maybe I'll put some PMOD headers on one of these cards. There's all kinds of things I could do. But turning this back on, that is working. So I'm really happy with that. Definitely look for any comments, questions any of you might have. If you see, again, something here that you think... especially on the FPGA soldering, anything that you see that I should have done differently or thought about differently, let me know. But I got this guy on there, and this one I just had it not hot enough the first time, and the second time I accidentally moved it and caused problems. So I think I've got a feel for what this now looks like, so the next one should be easier for me. Thanks for watching, everyone.